For question number 2, we're going to need to change the form of this equation so that we can get it into the correct form that we can read the information off of and then graph the hyperbola. And we do this by completing the square. So it's very similar to the process for ellipses. So I'm going to go to the next slide to do all of this work. And my first step is to organize my terms. So I want to put the x terms together and then leave a space. Then put my y terms together and then leave a space. And then move the constant to the other side. So to complete the square, we can't have a coefficient next to the square term. So the x's are okay, but we have a -4 next to our y squared, which means we need to factor that out. And I'm going to leave a space and then close the parentheses. Okay, so I'm ready to complete the square. So I need two numbers. My first number is half of the coefficient of the x term, so that'll be 1. And then I square that to get 1. So I'm going to add 1 here, and then to keep this legal, I need to add 1 to the other side. With the y's, half of -4 is -2, and if I square that, I get +4. So I'm going to add 4 here, but I'm not going to add 4 over here, because I'm actually not adding 4 here. That sounds kind of weird to say. But because this -4 is being multiplied by this parentheses, the -4 is actually getting multiplied by the +4. So I'm actually subtracting 16 here, because -4 times +4 is a -16. So to keep this legal, I actually need to put a -16 on the right-hand side. So if we finish with completing the square, these factor as perfect square trinomials, and we'll see those first numbers that we wrote down. So this is x plus 1 squared minus 4 times y minus 2 squared. And that's equal to -4. So that must be a 1 to be in the right form. So I need to divide by -4. This is going to become a negative x plus 1 squared over 4. These two negatives will cancel out, so it's going to be plus y minus 2 squared over 1 is equal to 1. So you can either write it like this, or if you always want to put the -1 second, then you can put the +1 out front. So either like this, or because the y is positive, put that first, the x is negative, put that second. Either way is correct. Okay, so because the y squared term was positive, this is going to be opening up and down. looking back at my formula, my h is -1, my k is 2, my a is 2, and my b is 1. So my center is -1, 2, my horizontal distance is 2, and my vertical distance is 1. So I'm going to draw this, and that's my center. So my horizontal distance is 2, so I need to go to the right 2 and the left 2. Vertical distance is 1, so I need to go up 1 and down 1. So this is going to help me make a box, and that box, or rectangle, is going to help me draw my hyperbola. So my rectangle goes like this, and I need to draw a diagonal line that goes through the corners. And it's kind of hard to do on this app. There we go. So if you have a ruler, that will help you draw it on the piece of paper. Okay, so this hyperbola we know is opening up and down. So these diagonal lines serve as the boundary. So they're asymptotes that my hyperbola approaches. When the hyperbola opens up and down, the transverse axis is vertical. So that's going to have a length of 2, and the ends of those are the vertices. So -1, 3, and -1, 1. So the conjugate axis is horizontal, and that has a length of 4. So these would be the covertices, and that would be -3, 2, and 1, 2. Lastly, I need to find my foci. So the c is going to be equal to the square root of 1 plus 4. So c is equal to square root of 5. So my 2 points are going to be -1, comma 2 plus square root of 5, and -1, comma 2 minus square root of 5. And that's going to put them about right here. It's kind of hard to see. And right here. And that'll be our hyperbola.